5.4, solving right triangles. When they say solving right triangles, basically what they mean is find all the missing parts. You're going to get some sides and angles. You'll have to find the rest of the sides and angles. Okay, so the first slide is about significant figures. You may remember this from physics class. It's really, I'm not going to make a big deal out of sig figs, but you can see some examples of, 3 sig figs or 4, okay, 2, 4, 2. Basically what they used to do in the old book was however many sig figs you saw in the problem, that's how many you would need to provide in the answer. But now that we have Math Excel, they're going to tell you what to round off to. They'll tell you to round off to 3 or 4 or whatever decimal places. Okay, so down here, you should notice that's 2 sig figs, and that's only 3, and that's 4, and that's 5. Okay, so they're talking about significant figures basically as a clue to what to round to. Again, just do what the problem says to do typically. Number 1 says solve a right triangle. Again, if you're solving a right triangle, you're finding the missing pieces, okay? So I think it helps a lot of the times to draw a picture. Since it is a right triangle, we know there's a right angle. Usually that's going to be angle C. When you draw your triangles, make your angles capital letters and make your sides, oops, not C, I've already got C. Make your sides lowercase letters. What I would do is I would label the things that they give me. They give me angle A is 34 degrees and 30 minutes, okay? Remember, we would want to convert. That's going to end up being 34.5 degrees, okay? We don't have to convert that, but I think it's going to be easier for us if we do 34.5 degrees. And then side C has to be across from angle C, that's 12.7. I would go ahead and label everything that I'm given in the picture. So I've got angle A, I've got side C, and don't forget they gave you a right angle, so we've got this angle as well. I need to find all the other missing parts, okay? So usually what happens is whatever they give you 2 of, it's easiest to find the third. So if you look at your picture, we have 2 angles. It should be pretty easy to find the third angle because we remember something from geometry. We remember that the 3 angles in a triangle always add up to 180. So we should just be able to go 180 minus 90 minus 34.5 to get, what do we get there? 55.5, okay? Want a calculator for this, so get your calculators out. 55.5. So I'm going to write B equals 55.5 degrees, and I'm going to circle it because that's part of my answer. I'm trying to find all of the missing parts. That's one of them. I think it would even probably help to label it in your picture after you find it. Okay? Get rid of that. All right, so I've got all the angles. I need some of the sides. So if you think about it, we are looking for side A, lowercase a, and side B. You have to do one at a time, and this is going to be a SOHCAHTOA problem. Okay, you've got a right triangle. It's not on the XY axis. It's probably going to be SOHCAHTOA. Now, here's a tip. I would try to use the number that they gave to me rather than the 55.5 number that I found. And the reason for this is in case I screwed up. Okay, if I messed up and 55.5 was wrong, or even if I rounded it wrong, if I use that number, everything after that's going to be wrong. So I'm fairly confident that 34.5 is a right number. I'm going to use that one. It's just more likely that my numbers after that will be accurate. Okay, so let's think about this. We can do SOHCAHTOA. If you look at the angle 34.5, I'm looking at opposite and hypotenuse. Okay, I can find angle or side A using sine. So I would say something like sine 34.5 degrees equals opposite over hypotenuse. Okay, Now, get used to cross multiplying. I don't want to have to write this every time, but you have a proportion, you're going to cross multiply. Try and do this, try and do that in your head, I suppose. I really don't want to have to do that, but you should be able to see that A is going to equal 12.7 times sine 34.5. And that's where we would need our calculator. Make sure you're in degrees. 12.7 sine 34.5, and in this problem it's 3 significant figures, so they intended for you to round to 3 significant figures. 7.19. What's the unit? Inches. Okay, so now we know this side is 7.19, and now all we need is B. Okay, I'm going to do B in green. So I suppose you could use Pythagorean theorem. You've got 2 sides of a right triangle, so that would be an option. All right, that would be an option. I think it's easier to use SOHCAHTOA though, because if I use this angle, I'm looking at adjacent and hypotenuse. I can just use cosine. Cosine is adjacent over hypotenuse. So I would say cosine 34.5 degrees equals adjacent side B over hypotenuse 12.7. Once I cross this up, 12.7 cosine 34.5 degrees. According to the 3 sig figs, it'd be 10.5. A little bit that bothers me. I'd rather round off to 2 decimals every time, but whatever. It doesn't really matter. Just make sure you do what the question tells you to do. Round off to whatever it tells you to do. So once we've found all of the missing parts, we are finished. We have solved the triangle. Example 2, solving a right triangle. So again, what I'm going to do is start by drawing a picture of it. I think you want to do this. I know a lot of times people want to be lazy and not draw a picture, but I really think it helps. Angles are capital letters. Sides are lowercase letters. Hypotenuse is C, so that means the right angle is C. Okay, so I'm going to label what they give me. They give me side A is 29.43 centimeters, and side C is 53.58 centimeters. In general, whatever they give you 2 of, it's almost always easier to find the third one. So I see 2 sides. I should be able to do Pythagorean theorem there for the third. Okay, so A squared plus B squared equals C squared. We can do 29.43 squared plus B squared equals 53.58 squared. Straight Pythagorean theorem. All right, so subtract this over. I'm going to kind of skip over something real quick. You're going to subtract that over, and what was it? 53.58 squared minus 29.43 squared, 2004.6915. You're going to have B squared equals 2004.6915. Notice what I did. I subtracted this over. And then we're going to need to square root that. So square root of that number gives me about 44.77. So B is 44.77 centimeters. All right, 44.77. I've got all the sides. I've got one of the angles. I've got to find the other 2 angles. Okay, now that's where trig comes in, because trig is going to be a good link between sides and angles. So pick one of the angles. I'm going to look at angle A first. Okay, so I would try to use the numbers that you were given in the problem, just in case I rounded off on my 44.77, Okay, if anything went wrong with 44.77, then everything after that is wrong. So I'm gonna try to use the green ones, 29.43 and 53.58. So if you notice, here's your angle. That's opposite, and that's hypotenuse. Sine is opposite over hypotenuse. So if I want to find angle A, I can say sine A equals opposite over hypotenuse. Now, this one's a little bit different than the last problem because you're missing the angle. Okay, so I always relate it back to a problem like this. If you're solving an equation with only one variable, you always undo those operations, right? Don't write this down. And you're going to subtract 4 and you're going to divide by 2. You're undoing operations, right? Okay, that's how you solve. And so it's the same thing with this problem. We're going to undo the math that's on the angle. We're going to undo a sine. And what's going to undo a sine? Inverse sine. This is not multiplication. We are not multiplying both sides. We are taking the inverse sine of both sides. So angle A is going to equal inverse sine of whatever that is, to 29.43 divided by 53.58. And you can divide that out if you want, but I'm just going to plug it all in. We're going to do an inverse sine of 29.43 divided by 53.58. Inverse sine of that gives me 33.32. A equals 33.32 degrees. I'm going to go ahead and write that in, 33.32 degrees. Now I've got everything except for that last angle. Okay, that last angle right here is B, but that should be easy to find if we've got two angles because we still know that property that angles in a triangle are going to add up to 180. So this is probably the easiest way of doing it. 180 minus 90 minus 33.32. But it's not the only way of doing it. You could do SOHCAHTOA again if you want. Do a different trig function or a different angle or whatever. But I would try to find the easiest way. 180 minus 90 minus 33.32. 56.68. B equals 56.68 degrees. Solving the triangle means find all the missing parts. I've got them, so I'm finished. Angles of elevation or depression. I'm not going to read all this to you. You can read it yourself. One thing that I would say is if you're depressed, you're looking down. Okay, so if you're depressed, you're going to be looking down, and so just think about that as you draw your picture. Angle of depression is if you were normal, you're looking forward, but if you're depressed, you're looking down. Okay, so that's a common mistake that people make is they don't think about that. All right, angle of depression is going to be underneath the line of sight or the horizontal line of sight. Okay, and that little caution down there says the same thing. You've got to look at that horizontal line. Okay, between the line of sight and the horizontal line. All right, so here are some application problems. When Shelley stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 5.3 feet above the ground, find the height of the flagpole. I really think this problem would be difficult without drawing a good picture. Okay, so I'm a huge advocate of drawing a good picture here. Okay, so it's going to be a right triangle. Just know that. So let's say Shelley's standing right here, and she's 123 feet from the base of a flagpole. Okay. So there's my flag. There it is. All right. The angle of elevation to the top of the flagpole is 26 degrees 40 minutes. So they're talking about this right here, and the angle of elevation is from horizontal, okay, from horizontal to that angle right there. Now remember, 40 minutes, if you were going to convert, you do 40 over 60, so that's going to be 0.6 repeating. So I've got 26.6 repeating degrees. Okay, I'm going to change it to decimals. It's just easier, I think, to deal with decimals. That's going to be a right angle, so we've got a right triangle. Okay, now the 5.3 feet. If her eyes are 5.3 feet above the ground, find the height of the flagpole. Okay, so Shelley is standing here, but really this is where her head is, because that's where her eyes are. Okay, she's standing here, and she's 5.3 feet above the ground, so you'd have to add that on, I guess. Over here is 5.3 feet, all right? So the kicker is, I think the important part of the problem is, oh no, I just decapitated poor Shelley. The key is you got to notice a right triangle, okay? So I want to know this number right here. That number isn't technically the height of the flagpole because there's going to be an extra 5.3 feet on, but we'll deal with that later. Let's just look at that as far as the triangle goes, okay? We've got an angle, and if you think about SOHCAHTOA, this would be opposite, and this would be adjacent. That's going to be tangent. Tangent is opposite over adjacent. This is a tangent problem, right? That's hard to see. I think that's hard to get without drawing that picture. But I'm going to set this problem up, and I'm going to say tangent 26.6 repeating equals the opposite side, x, over the adjacent side, 123. So when we cross multiply this, x is looking like 123 tangent 26.6 repeating degrees. And how I'm going to enter that on my calculator is I'm going to enter a whole bunch of sixes in there. Okay, I don't like rounding off. Just put in a bunch of sixes and that'll be like you barely rounded off. All right, so 61.8, let's call that 61.8. X is 61.8 feet. Now that's not the height of the flagpole. The flagpole is that plus this 5.3. Remember, Shelley was 5.3 feet tall. So the height is going to be 61.8 plus 5.3. That's 67.1. The height of the flagpole is 67.1 feet. Okay. Example 4, the length of the shadow of a building, 34.09 meters tall, is 37.62 meters. Find the angle of elevation of the sun. Okay, so you might start with the sun. I know you don't have a whole lot of room here, but make do. Okay, there's a sun shining on a building. Okay, and that building is 34.09 meters. Okay, so the sun shines down and it says there's a shadow. That building has a shadow that is 37.62 meters. And so again, if you think about it, that sun is shining and it's going to be making a triangle. Let's try that again. Okay. We've got this triangle formed. And assuming this is not the Leaning Tower of Pisa, this is a 90-degree angle right there. So we're looking at a 90-degree, a right triangle here, and they want the angle of elevation. So they're looking for this angle right here. Okay, so again, go back to SOHCAHTOA and look at what we have. Okay, we've got the opposite side and the adjacent side. So again, that's tangent. Tangent theta is going to equal opposite over adjacent. We're going to solve this with an inverse tangent. It's not multiplication. Theta equals inverse tangent of whatever that is when you divide. Inverse tangent, 34.09 divided by 37.62, 42.18, okay, 42.18 degrees. That would be that angle theta. That would be the angle of elevation of the sun.